你好，老师。哦，老师。
We can't hear you.
Hello. Now, hello everyone.
你好，老师。
Hi.
Yes, sir.
Okay, now here I think you can hear me, right? Okay.
Laoshi, we can hear you.
Okay.
Yes, ma'am, we can hear you. Israel.
And here, because this is the first time, in fact, I want to call the door, but there is something wrong with, because something wrong with this system. So for the first time, we do not call the door. Okay, next time I will call the door. And now we begin our class, and I will share the screen. And our class is this is advanced mathematics. First, this is not the time. Okay, you can omit this. Okay, ignore the time. We should know our textbook. Textbook, you can buy our textbook online, or maybe you can download the electric tab and print them. Okay. Anyway, so I hope you can take our textbook or your notebook. You should have a pen, because we will have do many exercise, because this is mathematics calculus, right? This is advanced mathematics, or we call it calculus. And here, this is here for this one. This is our reference book. And next, we will introduce why we should study calculus. Okay. Before go on, I also like to show something, maybe some questions for you. This is why we study calculus. This is a very natural question. Okay. So why? Why we study calculus? Okay, we may say, I think this part is very important for our students. we need to know what about our motivation for our course, especially students in college. We need to know why we study so many mathematical courses. For example, calculus. And we will spend a whole year to study this course. But why? Okay, this is a natural question. So why we need to study this course? I think this is a very interesting thing about the great contribution of calculus and Newton's mathematician to human progress. And we will have 4 problems for science and technology. Problem 1 is what's the relationship of the velocity? Okay, the velocity and the position function of the moving objects. We will learn the relationship of the velocity and the position function of the moving objects. And for example, a car is moving here, and we want to find its speed. Speed, if we know its distance, that means what's the relationship of the velocity? We write this is v, and the position function is we write s. So we know in high school we studied the physics. We know velocity is equal to s, the distance over time t, right? But I have to tell you this speed called the average speed. Okay, average speed in Chinese. Do you know this Chinese words? This is called 平均速度. Okay, in Chinese, the average speed is 平均速度. For example, you walk from the dorm to this building, but pass through the library. What about the velocity at the point of the library? Okay? Because in that point, you don't have distance, right? You walk from dorm to our building and you through the library. Now we want to know the velocity at the point of a library, because in that point, we know we don't have the distance, so we don't have the time. That is the time is 0, the distance is 0. So if we use the formula we learned in high school, this is 0 over 0, whereas it's meaningless, right? So how to find the velocity? Okay, the velocity is called, we will learn the instantaneous speed. Okay, instantaneous speed. And problem 2 is tangent line. In high school, if we have a line here, how to calculate the tilting of this line? For example, we have a line here. This is the x-axis, y-axis. This is 0, and we just this is the curve. Y is fx. We want to calculate the tangent line. We introduce the slope. Okay, the slope for this quantity. If we have theta here, so we define the slope of this line to be tangent. Honey. So we use tangent theta to calculate the tilting of this line. This means we have a theta. We use tan theta. Tan theta to represent the tilting of this line. Now we have a question. You are in our classroom? Oh, but we changed the classroom, you know, right? Oh, yeah, okay. 你叫什么？云莲。鱼莲。Okay, okay. Because B201, there's something with the students online cannot hear my voice. But I think next time we still study in B201, not in this classroom. I will take my computer and ensure students online they can hear me. Okay. Well, this is just a sudden accident, right? Now, if we have a curve, now we want to know how to calculate the tilting of the curve. This means we want to write the slope. I write this is k is tan theta, but we don't know how to calculate tan theta. Okay, and we will learn it after. And the third problem. The third problem is we want to calculate the length of curve or the area of general ridge in the plane. This means we know if this is a straight line. Apparently, it's not straight but we see this is a straight line. We know how to calculate the length, right? But here, this is not a straight line. This is a curve like this. Here, the start from point A and end at B. No, but do you know how to calculate the length of this curve? Okay, so we want to calculate the length of this curve. Now, we also know, for example, okay, oh, no, nothing. We know how to calculate the area of this. This is called the parallelogram. In Chinese, it's 平行四边形, or this is a square. The squares. We know calculate the area of squares. We know how to calculate with the area of this circle, right? But here I will give you, okay? Okay, but how to find the area of this ridge? This ridge, how to find the area of this ridge, and we will learn also later, okay? And here, if we have A here and B here, this means A here, B here, or A here, B here, how to find the length of the curve. So how to find the length of the given curve, and similarly, you know how to find the area of this triangle. For example, we have a triangle. I also know how to find the area of this triangle. But now, if we change this line to be a curve, if we have a curve something like this one, now the new question is how to find the area of this ridge or some other general ridges. Okay, the last problem. Problem 4, how to maximize or minimize our given function. Okay, for example, I give you a function is y is with x squared plus x 2/3 plus 2 and plus maybe is a little This is a function. I think this is a little complicated. Right, it is like think about okay, maybe this one, and maybe I gave you an interval A B. This is just a simple function. We want to find the maximum or the minimum on this interval. This is how to find. This is the last question. So those 4 problems promote our course. Okay? And the calculus can answer all of these problems from science and technology. The first 2 constitute the differential part. And problem 3 is calculate the length of the curve and the area of a general region. This constitutes the integral part. Okay, we will talk about it later. Problem 4 should be the application of the derivative. Okay, of the derivative. We will also talk about it later. So first, this is a requirement from the science and technology. We will answer these very basic questions. And we will introduce the main content of the course. This is what we will learn next. And advanced mathematics course is a compulsory and general education course for different students from industry colleges. Okay, the main content of the course detailed as follows. We will learn numbers, inequalities, absolute values, functions, limits and continuity, derivatives and application of the derivative, integrals, applications and techniques of integration, first order linear differential equations. All of this we will learn in this semester, okay? And we will solve these problems. And first, when we finish the course, this is some rules for our class. Okay, the first rule is you should not be late. Okay, and we will call the roll every time. This is just time we didn't call a roll, but next time and after we will call a roll every time. If you are not here, then I will record you are absent. Okay, this means maybe your score, your final score is influenced by your attendance, right? And we also here and this we have the course assessment. This in accordance with the regulations of school. Assignment result is an integrated calculation of the actual score of final examination. This means when we end this course, we will have the final examination and the average score of regular grades. The average score. The regular grades are graded by, this is the regular grades. Grading by your attendance, this is a very important part, okay? And homeworks, we will have some homeworks. We have to enforce the attendance policy from now on, okay? So if you are present in your class, please write down. This is because everyone in your class, you should write down your name. But here we change the way to change the way of calling the roll, and we just I call your name. You say you are here. Okay. Next time I will explain the roles maybe Mao, the Chinese is what? Where do we send them? Where? What? Attendance? No. Here, no. This is not this. Next time I will explain, okay? This is not. Okay, we change the door. Hello, students online. No. Hello, students online. Do not worry about the attendance, okay? Next time, I will explain it. Because the first time we have some accident, we change the classroom. Okay, next time, okay? Do not worry about it. And we also have some rules. This is, you should take notes. Okay, yeah, right. You should take a pen. And here, this is our book. Okay, right, perfect. So this is, this is the PowerPoint, right? PowerPoint. Also, this is also very important. Okay, you can, when you have this means you can review after our class. Okay, so let me see. This is your, this is our, this is also our, okay, it's good. Okay. Take notes, you should read the textbook after class to ensure your learning process. Because if you don't review, maybe next time you come here, you almost forget all we have learned. And then if we learn new knowledges, you may feel a little confused and you feel it's so hard for you, right? So don't be late, okay? This is not our rule. I just call it don't be late, okay? Because if you are late, maybe although you are here, but I will record you are absent. Okay, so this is our rule. Don't be late. Okay, and because of this is emergency, this means if you have something, maybe you can't attend our class, you should give me a note for leave in advance, okay? If I already record your station is be absent, now after this you explain it and you want me change your station. You want me, teacher, please give me attendance. I think it's hard for me to change it, okay? So, add in advance. And also, you can, this is not our class, you can also ask questions in our class, right? This means when we solve a problem or when we explain these problems and you don't know why. And I also will ask, do you understand it? If you have any questions, you can say, why you write it like this? Okay, you should ask questions. If you confused, you don't know why. Okay, but ensure you are listening to me carefully. Okay, this means when you are explaining or talking teaching you or explain very difficult problems, but you are here playing this is your phone, playing a game or talk with each other, and then after this you feel confused because you're not concentrated on, and then you ask me why. So I think this is your fault, right? And do homework. Okay, do homework. Okay, now we will learn chapter 0. This is preliminaries. Okay. Maybe in our class, I read the wrong word. If you know, I hope you can tell me how to pronounce it. Okay. And in this chapter, we will introduce some basic concepts and some useful tools of mathematics for our further study or research. For the first time, I think it is not hard for you to learn about this because I don't know. I think you have learned it before, but I'm not sure. Okay, and later we will learn. We will learn real numbers, side intervals, inequalities, absolute values, the rectangular coordinate system, functions and their operations, trigonometric functions. First, real numbers, side intervals. Okay. This is calculus is based on the real number system and its properties. But what are the real numbers and what are their properties? To answer, we start with some simpler number systems and natural numbers. Do you know natural numbers? Do you learn it before? Yes or no? Oh, this is, for example, 1, 2, 3, 4, 5, 6, and so on. And then we learned integers, right? This means include their negatives and zero. This is -4, -3, or -2, -1, 0, 1, 2, 3. So this integers. And we continue to consider this is the quotients of integers. This means, for example, this is 1, and the numerator here is 1, the denominator is 3. This is this is quotients, right? Quotients. This 1 over 3, 2 over 3, 1 over 4, 3 over 4. Or we write 6 over 5. This is the consider quotients of integers. Then we have the rational numbers. We know it before. Okay, we know it. Okay, rational numbers. These numbers that can be written in the form what? This is m over n. Right? M are integers. M over n, rational numbers. And we always remember that dividing by 0 is not allowed. Right? So this means you cannot 6 over 0, right? Okay. And then we have our questions. Do the rational numbers serve to measure all lengths? The answer is no. For example, we give a right triangle. This is the length of this is adjacent 1, and this is called I don't remember. This is called this line. We have a name. Is called maybe I forgot it. And we know the length of this line is the square root of 2, right? So the square root of 2 measures the hypotenuse of a right triangle with this is hypotenuse with length 1. But square of 2 cannot be written as a quotient of 2 integers. This means square of 2 we cannot write is equal to m over n, right? So this is not a rational number, right? And here we have irrational numbers. This means numbers that cannot be written in the form m over n, where m and n are integers with n is not 0. For example, the square root of 3, square root of 5, this is the cube root of 7, and the pi. These are irrational numbers. Okay, and then we have real numbers. This means if we consider all numbers rational and irrational that can measure lengths together with their negatives and zero. We call these numbers are real numbers. Okay, real numbers. And when the real numbers may be viewed as labels for points along a horizontal line. This is horizontal line. There, they measure a distance to the right or left, the directed distance from a fixed point called the origin. Oh, all right, this orange O, and labeled 0. Though we cannot possibly show all the labels, each point does have a unique real number label. For example, 1. This point, this means the distance between 0 and 1 is 1. So we write this is 2, or this is 5 over 2. Okay. This is minus 3 over 2. Here is the square root of 2. Irrational number is also on this line. Okay, and this number is called this number is called the coordinate of the point. And the resulting coordinate line is referred to as a real line. This means this line is called a real line. It's called a real line. And figure 4 suggests the relationship among the sides of numbers discussed so far. We know. First we learn the natural numbers, and then we learn the integers, and then rational numbers, and then real numbers. And then we learn to the order. This is the non-zero real numbers separate nicely into 2 distinct sides. The positive real numbers and the negative real numbers. This fact allows us to introduce the order relation. This is, we write with is less than. By x is less than y, if and only if y minus x is positive, right? It's greater than 0. The order relation here, this y is rate is less than or equal to. Is a first cousin of less than. Is defined by x is less than or equal to y if and only if y minus x is positive or 0. So we have the order properties. We learned that this means is track. I forgot this. Don't know how to pronounce this. No. No. Check maybe. Oh, okay. If x and y are numbers, then exactly one of the following holes. We have x, y are numbers. One of the following holes, x less than y, or x is y, or x is greater than y. The second property is the sensitivity. This means if x less than y, y less than z, we know as x less than z. The third is addition, means x less than y, and only if x plus z less than y plus z. The last one is multiplication. This means with here, we should notice z is positive. This positive x less than y, if and only if we multiply by both sides multiplied by z, x less than y z. Okay, here. When this negative, right? Negative. And x less than y if and only if here, you know, xz is greater than yz, right? For example, We know 1 is less than 2, right? But if we have a positive number, for example, 3, both multiply by 3. We know 3 is less than 2 times 3, right? But if multiply by a negative number, minus 3, this is greater or less than or greater than? Greater than, right? Greater than times minus 3. So we change the this is called change the order relation. Order purpose is 2, 3, and 4 in the margin box hold when the symbols less than and greater than are replaced by less than or equal to and greater than or equal to. And then we give the concepts of size. The definition, a site. Well, a site is a collection of all objects which are sharing some properties. Each of the objects belonging to a site is called an element of the site. Do you learn site before? Learned? Okay, have a rest. Hello, students online. Have a rest for a while.
谢谢老师。
Hello. Okay, I will.
What is it in Morocco?
And here we let the site and the element. Well, oh, I will lower my tongue, right? Lower the voice. Sites are always denoted as capital letters such as A, B, C, all right? Elements of a site usually are denoted as small letters such as A, B, C, and relation is an element of site A. Read as A belongs to A. This means this A belongs to A, right? A element. The relation we write A R O A does not belong to A. We write A this. And then give the finite side means finder consists of an element. This is called a finite side. Side containing no element is called an empty site. So denoted by this site denoted this. Okay. A site consisting of infinite number of elements is called an infinite site. Infinite site, for example, the natural number is denoted by the capital N. This is a natural number. An integer site is denoted by Z, integer site. The rational number is denoted by Q, is the rational. Real number is denoted by R, is a real number. We will learn the identification of sites. This means the elements of our site be numbers, but may also mean other things. For instance, the collection of all students in the same university can be regarded as a site with students as elements. So there are ways to representing the site. First, the partition is list all elements of the site. For example, the site of the equation x squared minus 1 is 0. That can also be represented by list all elements. We write A is 1 minus 1. Second is property. Point out the remaining property held in common by all the elements of our text. For example, for this one, this is the list of elements. We can also point out the element, property. We write A, x squared minus 1 is 0. So the second way to represent the element, the site. And then we will learn the relationship of size. Let A and B are two sides if each element of A is also an element of B. This means V is called a subset of B. Subset denoted by A set of B. Or we write B contains IC is contained by B, or B contains A. Now, the A definition could be right is if A is contained by B and B is contained by A, then A and B are equal. We write A is equal to B. Now we have this if A is contained by B but is not equal to B, then A is called a proper subset of B, denoted by, we always write O like this. And A is contained by B, we write like this. If A is contained by D but A is not equal to B, we write like this. This is the proper site. And there are some basic operations on site. Let A and B are two sides. We define the union of A and B is a site, which contains all elements of A and B, is denoted by A union B. Resize A union B. This means A union B, we have this is A like this. This is B, site B. A union B represents all the elements that belongs to A and B. This part, right? Okay, this part. This is X, we write A union B. X belongs to A or X belongs to B. And then we will learn the intersection. The intersection of two sites, A and B, is a site whose elements are those belong to both A and B. This is both A and B. Is denoted by A unit. This is intersection B. A intersection B. This means A intersection B is the site X belongs to A and X belongs to B. And A union B. A union B is X belongs to A. Here this is what? R, right? This is R, X belongs to B. X belongs to B, right? This is the R. But here this is AND. So if this is the set of A, set of B, so A intersection B is this part, the same part. If A intersection B is an empty site, then A and B are said to be disjoint, right? Disjoint. And then we learn the difference. The difference of two sites, A and B, is a site whose elements are those belongs to both A, but not to B. But not to B, denoted by A. The difference, we write A like this, like this. This means X belongs to A and X, this means does not belong to B, right? It's not belong to B. We can read as A minus B, or the difference between A and B. We always A minus B, right? This is X belongs to A here. This is X belongs to B, and X is not belong to B. So we should minus this part, right? Or exclude this part. So this shadow part. And then we learned this is B is contained by A. Then the difference A minus B is called the complement of B with respect to A, denoted by CAB here, B belongs to A. B, this is the contained by A. This is B, this is A, right? B is contained by A. The difference A minus B. A minus B. This, we write this A minus B. This is X belongs to A. X belongs to A. But X is not belongs to B. So we should exclude this part, right? So is this, right? Is this, that. So we write is CAB. CAB, the complement of B with respect to A. Complement. Remark, if the size which we are discussing are all the subsets of our set X, then X is called a universal set. X minus B is called the complement of B, denoted by CB or B, the upper is C. And we will learn those of operations and onsites. We have A, B, C, B, any three sides. Then we have commutative law. This is A union B is B union A intersection B is B intersection A. Second is associative law. A union B and then union C is equal to A union B union C, A intersection B, then intersection C is A intersection B intersection C. And the third is distributive law. This is A here. A union B and then intersection C is equal to A intersection C union. This is the union B intersection C. Do we learn this before? Yes? And A intersection B, then union C is equal to then A union C intersection B union. Okay, and this is A minus B, and then intersection C is equal to A intersection C minus B intersection C. The first is idempotent law. This is A union A is A, intersection A is A. And the five is absorption law. This is A union an empty site is A intersection. This is intersection. An empty site is an empty site. If we have A is contained by B, then A union B is B. And over here. Here is A. Here. This is B. No. A is contained by B. A union B is this site. It's, of course, it's B, right? And A intersection B, we want to find the same part. X belongs to A and X belongs to B. So this is A, right? This is A. And the third, this is called the in Chinese, this is called a 对偶. This is a dualization law, maybe. I think. If A and B are two sides of the universal set X, then we have A union B. This is complete set. We say this A, C union intersection B, the complement of B. A intersection B complement. A complement of A union this complement of B. And we should remark that in many programs, we use the concept about the product of two sides. The product of the sides A and B is a side consisting of all the pairs X, Y, where X and Y are any elements of A and B respectively. The product of two sides is denoted by A product B. Means that A product B is here, right like this. It's X belongs to A, Y belongs to B. For example, A is the side 1, 2. B is the side 1, 3. And can you write the side A product B? Can you write? Think about it. A product B. Can you write? Tell me the elements of A product B. Here X belongs to A. Y belongs to B. The A, we found the elements are 1, 2, right? So here we can choose X is 1. 1 belongs to A, right? So X belongs to A, 1. Y belongs to B, we can find 1, right? Also, X belongs to A, Y, 3 belongs to B, right? 1 belongs to A, 3 belongs to B. So it's 1, 3. And here we know 2 is also belongs to A, right? So we write 2. And we know 1 belongs to B, right? So when here Y is, this is X, Y, X, Y. And also 2 belongs to A, 3 belongs to B, right? We write this. So this are all their elements. This, you can find all elements you write front. You find all elements of B right behind. So they constitute the set A product B. For example, if here this is inequality X greater than or equal to A less than or equal to B. Here Y is greater than or equal to C less than D. So A product B is equal to, this is just X belongs to A. X belongs to A, they have the property this, right? Y belongs to B, they have the property like this. Of A and B. And the real number set is a basic set of advanced mathematics. Almost all of the main concepts are established on real number set. We have the property 1 is clear. This means A, B belongs to R. In A plus B, this is multiplied by B. A over B belongs to R, right? And property 2, out. This means any two real number A, B belongs to R. One and only one of following relations hold. Is A less than B is could be R is begin is greater than B. Is the order on the view line. We say X less than Y means that X is to the left on the view line, right? On the view line, we know the origin is 0. If this is -1, this is 1, we know -1 is less than 1, right? So -1 is -1 is to the left of 1, right? And we know -2 is less than 1, so -2 is to the left of 1. Okay? Here, if x is less than 1, x is to the left of y on the real line. Okay? And now we learn this is. We will learn intervals. Okay? We learn the size and now intervals. Intervals are a class of important numbers. Let AB belongs to R, the number set. Interval is also a set. It's just a number set. It's a number set. X belongs greater than A, less than B is said to be an open interval, denoted by AB. We learned the open interval. Yeah, AB. That is AB. We can also write AB is like this. For example, this interval 1, 2. This interval we can write is x is greater than 1, less than 2, right? This is the interval. And we will learn the number signs. This is equal. Okay, it's said to be a closed interval, denoted by closed interval, like this. This closed interval. That is, we write like this. And we have this means we have the site notation. Interval is also a site. So we can write an interval as a site. And we have this site notation. Here, this is interval notation, right? Here, we can give a graph. This interval. Open interval have a graph like this. And this, we can know, this is site notation. We can also write this is a closed interval like this, right? And we give the graph like this. Here, this open like this. Closed like this, right? Okay. And also, okay, and we have this is set notation. We notice this is greater than or equal to, right? So in interval, we write this left and set, they are different, right? Like this. And the graph also, left and right is different. Here, this is less than or equal to, so we write like this and like this, right? And here, x less than or equal to b, less than or equal to b. This means it's from minus infinity to b, right? So here, the graph, for example, this is b, less than or equal to b. So in this part, right? In this part, less than. So this here like this, here like this. So right like this. And greater than or equal to a, greater than. So we write like this. This is interval notation. Here, greater than. This is a, greater than. Write like this. Okay. Greater than a. Oh, okay. Just different like this. Okay. And here this is all real number. All real number. This means from minus infinity to infinity, right? And we have the graph. This is all real line. So like this. And then we will learn solving inequalities. What? Why we write open like this? Open interval, right? What? The graph of open interval. How to draw a graph of open interval? For example, you know, this is an open interval, right? How to draw a graph? Here, this is the orange is 0, right? We know 2 is greater than 0, so 2 is to the left or to the right of 0. To left or right? Right. And the 4, right? So the open interval, we just write like this. So graph like this. Okay. This R. This is okay. And R 0. This is not an open interval or closed interval, right? This means this is x. We write like this, draw like this, like this. Any question? Huh? Draw something? Okay. Yes, it's possible. Oh, you see this? No, it's not possible. It's not. Yeah, it's wrong. It's meaningless. This is what we don't have this symbol. It's mean. You can write like this. A site, for example, is this is for example like this. -1 program. This is 1. Okay, you need like this, but this part and this part they can't combine. You can this one means from minus infinity to 1. So if this is 1, this is minus infinity to 1, right? This is minus infinity, this is infinity, and this is 2. So this means 2 to infinity, like this, right? This is meaningful, but here, if you write, I don't know, this meaningless, okay? Hello, students online. Any questions? Oh, not by far. Okay. Okay, no questions. Now we will learn maybe the last content for today. This is solving inequalities. Solving inequalities as with equations, the procedure for solving an inequality consists of transforming the inequality one step at a time until the solution set is obvious. We can perform certain operations on both sides of an inequality without changing the solution set. In particular, we can add the same number to both sides of an inequality. We know A less than B. If A less than B, please tell me the relationship between A plus and B plus C. Which one is bigger? One, A plus C and B plus C. Which one? The question is A plus 1 less than or greater than. Please tell me this is less than or greater than. This means we have A is less than B. Please tell me A plus C and B plus C, the relationship of which one is bigger? Oh, just the comparison between A plus B and B plus C. Yeah, right. For example, 1 less than 3, right? And 1 plus 2, 3 plus 2. They both sides add the same number, 3 less than, right? This means the order is not changing, right? The order. So we can add the same number to both sides of an inequality. This we can without changing its solution set. Okay. And we may multiply by both sides of an inequality by the same. This is positive number. A positive number. And we may multiply both sides by the same negative number, but then we must reverse the direction of the equality sign. Reverse the direction of an equality sign. And I hope you understand this. Kind of 1 less than 3. And both sides multiply both sides by a positive number. 1 times 2, 3 times 2. Without changing the order, right? But if we times minus 2. Please tell me which one is bigger. It's 1 times minus 2, 3 times minus 2. Which one is bigger? This means both sides multiply by a negative number, right? And we calculate the left side. This is the minus 2, right? But here this is the minus 6. Which one is bigger? Minus 6 is bigger. Minus 2. So this we have reverse, right? Reverse the direction of the equality sign. But here, if we multiply by a negative number without changing the order. If we multiply by a negative number, we should reverse the equality sign. Okay, I hope you remember this. Now we can solve the equality and show the graph of its solution set. And without see the answer, we can do by ourselves. Here, this is 2x minus 7 less than 4x minus 2. Oh. And we can add adding the same number. Adding same number without changing is out. This means both sides adding 7. We can add this 7. This is 2x. This is plus 0, right? And 7 less than 4x minus 2 plus 7, right? And we have this is 2x less than 4x plus 5, right? Plus 5, and then we want to perform, we want to transforming the equality one step at a time until the solution set is obvious. So for this, we can both is the adding, we can also add minus, we can all, this is the adding minus 4x. Both as adding minus 4x. Just 2x minus 4x. Plus place minus 2x, right? Then we want to solve how to solve this inequality. Multiply both sides by minus 2. Multiply by both sides by minus 1 over 2. Okay? This is multiply by a negative number, which reverse the direction of the equality sign, right? So this means we have minus 2x times minus 1 over 2, the left side. Right side is 5 times minus 1 over 2, right? So we should reverse. Here, there's less than reverse, like this. And we find this is with x, right? Right is, so we have solved this, right? And then we still the graph of its solution. This is 0, this is minus 5, like this, right? Like this, greater than this. So, any questions? Any questions? But you know, I first I did 7 because I want to here this 2x. I want to let this is 0, but is 0. And why adding minus 4x? Because I want this part 0. So we only have this part and right only 5. So, and then I want to multiply both sides by minus 1 or 2. This means I want to this is just x. Okay. So, and I will give you an example. You finish it by yourself. An example, you can do it